Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we investigate an interesting software development skill or technique, come up with a challenge related to that skill, and solve it live on stream. This week we're continuing our exploration of building a microservice without mocks. We're building it from scratch without using mocks or broad integration tests. This week, we're going to be looking at responses. We're going to be creating robust, reliable responses. If you'd like to follow along, you can check out the code from GitHub, github.com/jamesshore/livestream. Check out the tag 2020-06-09. Your question and comments are welcome. As always, just go ahead and put them in the chat. I'll take some of them as we go, and we'll also have a little bit of time at the end for more questions. This is a really big topic. We've got a lot of ground to cover, so let's go ahead and get right to it. What we're going to be doing is continuing our microservices without mocks exercise. We're going to be building the response part of our Route 13 service. That is what we're building. We're building a RAS, Route 13 as a service. The fictional business owners of this little business have decided that that's the lucrative market they want to capture. They're not going to have much luck, but we're going to build the technology. So what we did last week was we built a Route 13 server application, and we built an HTTP server for that server to use. HTTP server is a little infrastructure wrapper, and last week we got the ability for it to start and stop. Now we're doing this all without mocks. And why are we doing that? Well, I've covered it in previous episodes, but very briefly, tests that use mocks are solitary tests. They are very good at checking that your code actually works in isolation and that it calls its dependencies, but it does not check to see that it calls the dependencies correctly. So we, instead of using mocks, we are using sociable tests, overlapping sociable tests. They are unit tests that check that our code works and also checks that not only does it call the dependencies, but it calls the dependencies correctly. And that has a lot of value. So that's what testing without mocks is all about. That's what this microservices without mocks exercise is all about. And again, what we did last time was we built the Route 13 service. We built an HTTP server that could start and stop. And now what we need to do is we need to have our service respond to requests. Specifically, what we're going to do is we're going to have it print a request received when a request comes in, and we are going to return a little placeholder response. Now, there's a couple of questions here. First, how do we build robust, reliable response code? And second, how do we make it testable? Those are the two things that we're going to be looking at today. I'm going to let you go ahead and chew on that. While you're thinking about that, this show is made possible by the fine people who hire me to do training and consulting for them. There's a variety of companies that typically smaller organizations, late-stage startups that have the capacity, the capability for a lot of business agility. They're very flexible. They want to move quickly, but they don't have the technical capacity they need. Often they find that as they grow, the way their teams work together breaks down. There's a lot of bottlenecks that form. So they bring me in to help with everything from agile engineering practices, training and coaching, all the way up to consulting and sort of organizational development around how their teams can work together. If you'd like to join this group of people and have me help your company, go ahead and send me an email, jshore@jamesshore.com, or you can visit me on the web, jamesshore.com, or you can tweet me at James Shore. There's a trend here. I'm pretty sure you can figure it out. I would be happy to help you no matter how you contact me. Just give me a call or send me an email, and we'll talk about what is going on at your company and how I could possibly help. All right, let's get back to the challenge. We are going to have our microservice respond to HTTP requests. And how are we going to do this? Well, we've already built an infrastructure wrapper called HTTP server. It has the ability to start and stop. And we have this Route 13 server, which is our application, our overall application. So what we need to do is we need to modify this code to support responses. And we're going to do this in the same way that we did last week. We're going to use programming by intention. We're going to build a nullable infrastructure wrapper, and we're going to use behavior simulation. Now, we talked about this last week, and if you missed out on last week's episode, or if you want to learn more about the things we're talking about, you can find all the previous episodes right down here, jamesshore.com/blog/lunchandlearn. Last week, we started this. We built the initial server. The week before that, we talked about testing without mocks. There's lots of other good episodes there, so go ahead and check it out. So again, this week, programming by intention, nullable infrastructure wrapper, behavior simulation. We are going to, programming by intention, briefly, is writing your code as if all the functions you needed already existed. So we're going to go into our route 13 server and we're going to modify it so that it can respond to requests. Then we will update our HTTP server. That's our nullable infrastructure wrapper. That's wraps the underlying node.js HTTP library and does it in a way that can be nulled out, so you don't actually have to run the server. And to test this code, we're going to use behavior simulation. We're going to modify our HTTP wrapper so that we can simulate a request without actually having to make a real request. That is how it's going to work. If you'd like to know more about these techniques, check out this blog post, jamesshore.com/blog/testing-without-mocks. Okay, we have a lot to do here, so let's get into it. If you would like to follow along, you'll need a copy of node.js installed, but then you can just download the code from GitHub, github.com/jamesshore/livestream. The tag again is 2020-06-09. At the end of today's episode, I'll check in the finished results using the tag 2020-06-09-end. So that's how you can find it. Now, if you do want to follow along, install Node if you haven't already, download the code, and then you can use build.sh to build and test the code. You can use build quick to only build and test things that have changed, and you can use watch to automatically run the build whenever files change. And when you do, you'll get a nice little sound like that tells you if this build succeeded or failed. To run the build, use run.sh, and that will, or to run the code, use run.sh. On Windows, it's build, watch, and run without the .sh part. Okay, so what we're going to do is we're going to start out by programming by intention. So we've got our route 13 server application right here. And the way it works is it's very simple. We're just going to start the server, and then we write that the server is started. And that does, in fact, work. You can see it right there. But of course, it doesn't respond to requests. So that's what we need to do. Now, the normal way that this works in JavaScript, and this show isn't really about JavaScript, but I had to choose some language for an example, so I chose Node.js. And the way things normally work in Node.js is you say something like server on request, then you get a request and a response, and then you do something with this. And we could do that. But the advantage of programming by intention is that it allows you to think about how do you want to write your code so that it is simplest to use and least likely to have errors. This approach right here, this on request approach, it's nice and generic, but our code isn't generic. It has a very specific purpose, which is to serve responses to our microservice. So it's just about our microservice. That's all it's about. So we don't have to be so generic. So one thing that I think about when I'm programming by intention is how can the bozo who's using my code, how can I make sure that they use it correctly? Because one thing that I know about writing APIs and libraries is that whoever's calling it is going to call it wrong. And unfortunately, most of the time, that bozo is me. So how am I going to write this code so that in the future, I use it correctly? So the other people on my team who are not bozos, the other people on my team can use it correctly. Something like this, I have to know to do this correctly. So I have to remember to write this. So what if we could write our code so that it told us if we weren't using it correctly? Well, we have type checking built into this so that if we don't pass the right parameters into start async, our code will fail right away. And that's called failing fast. And it's nice because even the sloppiest programmer will generally check their code manually. And if your code fails fast, then it won't work and they'll have to go fix it. So instead of requiring us to remember to use server.onRequest and maybe spell this wrong or something like that, what we can do instead is we can pass in onRequest as a function. And if that function doesn't exist, then the start will fail right away, and that would be nice. So let's do that. Let's make a function called onRequestAsync and have that actually do the work. Now, in Node, typically, again, you'll pass in the request and the response, and the way you'll do this, you'll say response.statuscode equals 501. We're going to do a little placeholder, so we'll return not implemented. And then you'll do set header and content type, text plain, char set equals UTF-8, and then you say response.end, not yet implemented. This is what we actually want our code to do as our placeholder. But again, this is error prone. I have to remember to call each of these things, and if I don't, there's a bug. So how can I write this code so that we don't have that bug? In addition, if we do it this way, now our tests are a little more complicated. We've got to inject some sort of response that isn't a real response, or maybe is a nullable response that will work correctly. So when I think about this, I think I'd like to make this better. And to be honest, the first time I wrote code like this, the first time I wrote a server in Node.js, I just basically did something like this. I injected a nullable response, and then I told it to send this stuff out. But there is a better way, and that is that rather than calling methods that we could forget to call, what if we just returned a data structure that had all the things that we wanted in it? What we can do now is we can type check this data structure. And if it doesn't have absolutely everything that we need, we can fail fast. The nice thing about this is now it's purely functional. Now our function is just returning a result. It's not calling any methods. And this is easier to test, it's easier to reason about, it's easier to write. So this, I think, is what we want to implement. Again, this is programming by intention. We write the code that we wish we already had. So this looks pretty good. Of course, this is going to fail. If I run this code, the test will fail because there is no onRequestSync parameter for our start async. And if I run it for real, it will fail. Boom. Yeah. So what we need to do is comment this out and get it back to the point where it was working code. And now we'll go into our HTTP server infrastructure wrapper and we'll do it for real. So here we are in our infrastructure wrapper. What this is doing is when you call start, it starts listening for the server. It will reject if there's an error. It will resolve if it's successful. By reject and resolve, I mean it returns a promise. So that's complete or fail is basically what resolve and reject are. And we have the ability to stop. So not super complicated. Let's go ahead and add the next piece. We've got a bunch of tests around starting and stopping. Now we need to have some tests around requests and responses. Now, as usual with infrastructure, the challenge here is actually coding the infrastructure. How are we going to actually make this code respond to requests? So let's go ahead and write a test describing what we want to do. What we are going to have it do is it runs a function when a request is received and serves the result. And let's just see this test run. There we go. Okay, so as normal with infrastructure, the challenge is just figuring out how to make the infrastructure work. We're going to spend most of our time this episode on that. The actual testability part, super easy. It's just getting the code to work properly is the problem. Now, I don't have to use a nullable I don't have to use an infrastructure wrapper, but I am going to have to write this code no matter what. And putting it in an infrastructure wrapper means that I'm not having to debug or look at this code in the future. I'm going to write it once, I'm going to make sure it works by testing it, and then I'm done. And then it's out of sight, out of mind. And so it is a lot of work to get this to work, but this is work I would need to do anyway. I'd just be doing it over and over again if I didn't wrap it up. Or I'd be testing it manually, which again is maybe convenient the first time, may even be convenient the second time, but by the 15th time, it gets a little old. So how are we going to do this? Well, we're going to need to start and stop our server. So we've already got some code to do that set up. So let's run that. We'll say start and stop async. And what this does is this is going to start the server. It's going to run whatever code we have right here, and then it's going to stop the server. So this should work just fine. And it does. Now what we need to do is actually make a request. The way you do that in Node is by using http.get, and you pass in parameters. In this case, the only thing we care about is the port. Everything else is default. It's localhost. We don't care what the URL is, and so forth. So if I do this, and again, when I'm figuring out infrastructure, I'll just hard code everything, and I'll use console log to make sure I understand what's going on. And then once I have control over it and I know how it's working, then I'll convert it to production code. So here I'll say sending request, and that should now say sending request over here, except it's not awaiting. So I'll need to await a new promise. There we go, because we don't want this test to exit until the request is done. So we're sending the request isn't done, so it times out. Now over here we need to receive the request. And the way you do that in Node is by saying server on request, then that will give us the node request and the node response. So we should be able to say received request here. There we go. Sending request and received request. That's good. Now we need to send a response back. And the way we do that in Node is just by saying whatever the response is and then some response. So now we should see it say sending request, received request, sending response. Good. And then it times out. Back in our server, now we need to be able to receive that response. And the way we do that is we say request.onResponse, then we get a response and we can do something with it. So here we'll say received response. Sending request, sending response, received response. Perfect. It's still timing out, so now what we can do is we can say on the end of the response, let's resolve our promise. But it didn't get that resolution, and the reason for that is because by default in Node, it waits for you to consume all the data before ending the response. But here we're not consuming the data, so we're just going to tell it to resume receiving the data without us consuming it. So now this should go all the way through to the end and exit. And there we go. Okay, let's actually see this. I am going to add an on air to this, just in case we get an error. Although I don't expect that to come up. And now that we are successfully sending the request, receiving the response, let's look at the results that we get back. So we're going to want to look at the body in some way. So let's write the body out. And to get the body, we'll need to make a variable to hold it and then listen for data on the response. And we'll take each chunk of data and we'll accumulate it into that variable. And there's our body. Very good. Okay, let's look at the status as well. There's our status, 200. Excellent. And let's also look at our headers. There's some headers. Very good. Now let's see if we can control these over on the server side. We'll set the header, or we'll set the status code to 999. There it is. And let's set a header as well. Okay. So now we've hard-coded everything. We've proven that we understand how the server code's going to work. Now we need to turn it into a real test and real production code. So let's come back to our test here. And in order to actually turn this into real production code, I'm going to need to be able to assert on this in some way. And I could write my assertions right here in the end, but I'm going to want to take this. I mean, this is a huge mess. It's really just nasty. So I'm going to want to take this, I'm going to want to factor it all out into something like, I don't know, get async or something. So what I want to do is instead return these back so that I can make assertions on them out here. The way to do that is I can resolve status headers and body here. And then I can have that return out of our inner function and then be received here. Now for that to work, start and stop async is going to have to return what it gets, which it doesn't yet. So let's go ahead and return that here. Now, if I've done that correctly, we should still see everything show up here, and we did. Good. Okay. So now we're getting the data back out here. Now we can actually write our test. So what we're going to want to do is we're going to want to have a function called onRequestAsync, and we're going to want that function to return a bunch of stuff. Let's start with status and say status should be 777. And then down here, we'll assert that the status is 777. Now this is going to fail because we're getting 999 instead. Well, and also I need a semicolon. Let's try that. So now what we need to do is we need to pass this onRequestAsync into our server, have it actually use it, and make an assertion on the response. But before that, we need to have the ability to pass this onRequestAsync through. So let's go ahead and pause here for a moment and look at how we start the server. And we're going to need to pass in onRequestAsync. So what I'm going to do here in start async is I'm just going to take some options. And because those options are optional, I'm going to have it default to an empty object. We'll run this test, and I'm expecting that this will now fail because start async does not expect an onRequestAsync. And that's exactly what's happening. It's saying that onRequestAsync was not expected. So up here in our type checker, we can say onRequestAsync is a valid parameter and it's a function, and we'll pass it in here. Okay, it's still failing. On request async must be a function, but it was undefined. So we'll come back into here and let's provide a default. Just default it to an empty object. And this is something that I'll do very frequently in my code, is I like to use helper functions to run the production code, and then I have options that I pass in that not every test is going to use every option, so I default it to certain values. Just whatever the happy path is, whatever is going to make the tests that don't need to set that value work, I'll set in the helper. Now, when we ran that, we saw that it's still failing, and it's failing in our Route 13 server. And this is exactly why I like sociable tests over mocks, because we made a change to the signature of HTTP server, and our Route 13 tests failed because they're not using on request async. Now, if I was using a mock-based test, it would say everything's fine, because it would say, I expect start async to be called with a port, and it was called with a port. That's how the mock-based tests work. They check that the dependencies were called with what you expected. Whereas a sociable test checks that it was actually called correctly. So here we're going to need to use on request async. And we'll make just a do nothing on request async to satisfy that. And now our tests pass. Okay, so back in our request test, we had turned that off because we didn't have the ability to pass on request async through. But now, well, actually, we still don't really have the ability to pass it through, because we're providing options to start async, but not start and stop async. So we're going to need to pass our options through here, and we're going to need to get them here. Now, because start and stop async takes a function parameter, there's no easy way to make the options optional. It is possible, but it's kind of ugly. So I'm going to take this, I'm just going to search for it, and I'll just pass in no options for most of these cases, except here in our new test. Okay, now we're passing our on request async through to our server. Let's go ahead and run this test. We're expecting that we're going to see a status of 777 come back. But it's not, and that's because we're not using it. Now in our server, in the request, what we can do is we can say that our status is going to equal the results of on request async, and here we can set the status like so. And that, I'm hoping, will work. We'll need an async here. And there we go. Now let's do the body. And we'll expect the body equals my body. But it's not. But that's easy. We'll just pass that through here. There we go. And now we'll do some headers. Let's say header 1 should equal value 1, and header 2 should equal value 2. And then down here, we'll assert that that's what we actually got. Okay, here we have a little problem, because the server is actually returning a bunch of headers that we don't care about: a connection, a content length, and a date. And the date especially is going to be changing all the time. So we do not want to be looking at that. But honestly, for our test, the only thing we care about is the headers that we're explicitly setting. So what I can do is I can come up into our Git code, and I can actually just delete out the headers we don't care about. And so that's what I'm going to do. I'm going to say delete headers.connection and content length and date. And now we're seeing that we're expecting header 1 and header 2. We're getting my header. That's perfect. So coding this should be pretty easy. We'll get the headers here. Then we're going to want to loop through all the header entries. So the way we do that is object.entries headers. That will give us an array of name value pairs, tuples. Then we can loop over that array. And for each one of those, we'll have a name value tuple that we can now set the header on. Oops, let's do it this way. And I think that will work. And it does. Excellent. So now we have a working code to send responses. We have working code to test that we're sending it. It's super ugly though, so let's clean this up. I don't think we need this anymore. And we don't need this. The logs have done their job. We don't need that. And we've got this big mess of sending the request. Let's take that and let's factor that all out into a method called getAsync. And I'm going to take that and put it down here. Okay, and I think this is about as clean as it can get. Oh, I don't need this response.resume. That was left over. Yeah, I think that's about as clean as I'm going to be able to make it. So back in our test, well, this code is duplicated. So let's take this and make it a variable. Let's call it expected response. I'll put this up here, and I'll make this an one-liner because I like my one-liners. You might not, and that's okay. And now that we've done that, we should be able to say that this is our response, and we're going to assert that our expected response is equal to our actual response, and that should all still work. There we go. That's good. And looking at our production code, that looks pretty good. Okay. So that's our happy path, but of course when you're writing code, happy path is just the beginning. The more important part, I think, is actually dealing with all the possible errors that could happen. And when I think about what we're doing here is we're saying you can pass in, oh, you know what, before I get into that, I think I want this to be an object, because if we expand it in the future, I would like that to be easy. So let's do it that way. Okay, so we've got the happy path taken care of, but happy path is really just the beginning. And when I think about what we're doing here, we're passing in an arbitrary function into our server. And I know that I'm going to get that wrong because I make mistakes all the time. I get everything wrong. And one of the things that I could get wrong is, well, I could make some mistake that causes it to throw an exception. And if we do that, we're going to want this code to fail gracefully. So let's do that. Let's say that it fails gracefully when request handler throws exception. So we'll have that throw an exception, and then we'll see what the response is. I think I want this response because this is going to be production code, we don't want our production code to be throwing an exception when it receives a response. Instead, we're going to want it to log an error for us to take action on. Now, we don't have the ability to do logging yet, but we are still going to need to return some sort of valid response back to the client. So let's say that the response here is going to be 500, which is internal server error, and a header of content type text plain char set equals UTF-8 and a body of internal server error. And then let's provide a little bit more explanation. We don't want to put the actual error because that's leaking internals back to our callers who have no control over. That's bad form. We really just want to log that information. But what we can do is say that request handler through exception. So let's do that, see what happens. Yeah, it's just blowing up. That's pretty bad. So we're going to need to come into here, and what we want to do is we want to surround this with a try catch. But if we do that, now we have the problem of how do we get this data cleanly back out? And I think a cleaner way to do this would be to take this code and extract it into a function that does the try catch and returns what we need. But to do that, I'm going to set this test aside for a moment. And I had to restart that because the server hadn't been stopped because it failed in such an ugly way. We're going to set this test aside for a second so we can do our refactoring and have our tests actually work. So I'll take this and I'll factor it out into a new method or a new function, and I'll call that handle request async. Take that, put it at the bottom. And now, that's still clean here. Now we can put a try catch around this. So let's go ahead and re-enable this test. Fails ugly again. Let's go ahead and kill that. And we'll say try catch. And then here we can return what we want, which in this case is status 500. Well, basically all of this. Okay, let's see if that works. It does. Excellent. So that's handling the request handler throwing an exception. Now, there's another thing that the person using this could get wrong, that I could get wrong, and that is, what if I don't return the right type of response? What if I forget something or I just don't return an object? We're going to want to fail gracefully in that case as well. So we'll make an onRequest async and have it return an invalid response. And then we'll do, I think we want to basically do the same thing. We'll call getAsync, we'll check the response, and let's say that the request handler returned invalid response. I run that and it fails in an ugly way again. And that's because the request handler is not throwing an error, so the error catcher isn't catching it. What's happening is returning result up to here, it's trying to destructure a string, and that's not possible. So it's giving us this error, cannot convert undefined or null to object. So yeah, that's no good. So what we need to do is have this fail correctly when the type is wrong. And we have a type checker already. So let's get the response. And we have this ensure, this little bit of runtime code that I wrote. And this is actually not an MTM library. It's just something I wrote years ago. You're welcome to borrow it. It's in the repo, in the livestream repo. But I don't officially support it in any way. So we're going to take that response and we're going to say that we expect it to match the response type. And that response type is an object that has a status, which is a number, a headers, which is an object, and a body, which is a string. If I do this, we should not fail quite so ugly. I've got to restart because it didn't stop the server when it failed so badly. It is still failing. Okay, I'm doing something wrong here. It's saying, cannot destructure property status as it is undefined on line 41. Oh, haha. I need to, down here, I need to return the response. There we go. Okay, good. Now we're failing gracefully, but we're not failing with the right error because ensure.type throws an exception when it fails. So what we need to do is we need to dig a little deeper into my bag of tricks, and we'll get the type error by calling type.check response. What this code does is instead of throwing an exception, it's going to return a string explaining whether or not there was an error. And if there was no error, it will return null. So if it's not null, what we need to do is return the error we want. Which in this case is internal server error, request handler returned invalid response. And we're going to need to import that type library. And there we go. Now everything's working. Now we are failing correctly when we throw an exception, and we're failing correctly when our request handler doesn't return a good response. Now when I look at this code, I see a lot of duplication. I see it here in our production code, and I see it here in our tests. And the duplication in the tests doesn't bother me. There's a great saying, I don't know who made it, but it's keep your production code dry and your tests wet. So don't repeat yourself dry in your production code, but write explicit tests. Wet tests, write explicit tests. We want a little bit of duplication is okay in our tests because it makes the tests easier to understand. And we're not changing the test all the time like we do with our production code, so it doesn't hurt so much to have some duplication there. So I'm okay with this duplication. But over here, this is no good. So let's take this. They're basically the same except for the message. So we can factor that into a variable. Let's call that message. And we can take this and factor it into a variable. We'll call that message. And now we've got basically the same thing each time. So I can take that and call that internal server error. Let's take this and make it a little bit more explicit. And now we can inline this. Well, let's make sure that works. It does, and we can do the same thing up here. Then we can inline this. And inline this. And I really like the way this reads. This is the nice thing about pure functions, is you get stuff like this where you can say return internal server error. That's just beautiful. I love that. Charlie Pancakes says, I always thought wet stood for write everything twice. You know, maybe it does, because they do say that 3 strikes and then you refactor. It's okay to have 2 pieces of duplication, but when you get the third one, you should refactor. But I've always heard it as write explicit tests. But maybe it's used both ways. I don't know. Okay, so we have some nice clean code. It fails gracefully when we throw an exception. It fails gracefully when we return an invalid response. And of course, it handles actual responses. I think this code is done. Let's check it in. So HTTP server now handles requests. So now that we've gotten our infrastructure wrapper coded up so that it can handle requests. Now we can go back to our top level application server code and we can modify this. But before we can do that, we need a way to test it. We need a way to see that the requests, to have our test simulate a request. Now we could serve the real server and then write some code to send a real request, but that's really ugly and it's slow. So this is where the behavior simulation comes in. So I'm going to modify our HTTP server to say that it simulates requests. And I'm putting this test close to the top because I like to have my tests, I like to have my tests read sort of from most generally useful to most nitpicky and specific. So when somebody comes along and looks at this in the future, they can say, oh yeah, this is the basic thing. This is the happy path. Oh, and this is something else I might want to do. Oh, and here's all the special cases that I probably don't need to worry about. So to simulate a request, we're going to need a server. I could use a real server, but it's probably more convenient for me to use a fake server. So I'm going to create, or not a fake server, but a null server. So I'll create that null server. I'll start that null server. And then I'll say server.simulate request. And we should expect some sort of result. I guess we're going to need our simulate request to return the response from the server. So let's get that response and let's assert that the response equals the expected response. When I just realized this should have been the other way around. Should be it was expected response, comma response, but it should actually be response, comma expected response. Make sure that still works. This test is half broken. Let me get this working. Line 80. There we go. Okay, so let's bring this back. So we want to assert that the response is the expected response. Expected response, we can do same thing again, basically. Oops. And then, of course, we're going to have some way of handling requests. And we're going to need to pass that in when we start our server. Okay, I'm expecting this to fail. Come to think of it, this should be async. I'm expecting this to fail because simulate request async doesn't exist. So let's take a look at that. This is start async. Yeah, simulate request async is not a function. That's exactly what we expected. So we can go back to our production code. We can add a simulate request async. And let's just have that return an empty object for now. See our test fail. There we go. So now to code this, we want to run the exact same code that our real request handler runs. And fortunately, we've already factored that out. We already have this handle request async. So all we need to do is return handle request async and pass through on request async, which we can put as an instance variable like this. And then up here, we'll save it off. Oops, that's on request async. And that should just work. And it does. It's running all the same code that our real code is. So it's going to fail in exactly the same ways as our real code. And that is really nice. Now, just as before, we're handling the happy path, but we should also handle the sad paths. First, I probably should put a type check on here just in case. I don't generally write tests for my type checking. It's just because it only fails if I'm doing something wrong as a programmer. And it's too much work to write tests for this over and over again. But I am going to make sure that things still work with that in there. And then the other thing that could go wrong here is on request async may not be initialized. It's only initialized when we start the server. And it doesn't make sense to simulate a request on a server that isn't running anyway. So let's say that it fails fast when server isn't running. Or simulating requests fails fast when server isn't running. So make a null server, and this time we won't start it, and we'll just assert that this throws. And it's going to throw can't simulate request because server isn't running. This assert throws async, by the way. This is just a little, this isn't part of chai, which is the assertion library I'm using. I wrote a little wrapper around chai and added a couple of functions that it didn't have, and assert this throws async was one of them. I find that in general it's good to wrap your assertion libraries because you're always going to want some special purpose assertions that only apply to your code that the general purpose library doesn't provide. Or if for some reason the library stops being maintained, then you can change the wrapper without breaking all your code, which with tests is a big deal. You're going to have the assertions everywhere. As always, third-party code, just a good idea to wrap it up so that when it changes in a way you don't want or stops being maintained, you have recourse. Anyway, this is going to fail because the exception isn't being thrown. That's easily fixed, though. We'll just come through and say, if we haven't been started, we'll throw a new error. Can't start server, or can't simulate request because server isn't running. There we go. And now we have simulated a request. We can check that in. Odino asked, do you write tests for the third-party wrappers? Yes, I do, actually, but only for the part that I wrote. I'll show you that in just a moment. So let's see, we've added HTTP server.simulate request async. So yeah, if we look at this utility wrapper I have, here's my assert, which is just got throws async and does not throw async. And I've also aliased equal to strict equal because type errors are really common in JavaScript, and there's no point at which I want it to coerce my types for me. And I do have tests around that. I didn't test the alias of assert to or of equal to strict equal, but I did test throws async and does not throw async. And again, all this code, I haven't open sourced this. Well, the whole livestream code base is open source. It's with the MIT license. I haven't published it to NPM, but you're welcome to use it if you find it useful. All right, so now we have finished the three things that we set out to do. We've used programming by intention to define our API. We've updated our infrastructure wrapper to support responding to requests. And we've added the ability to simulate requests. So now we're ready to actually finish this code up. We can start by writing a test. We'll say that it responds to requests with a placeholder. Charlie Pancake says, I notice you're not using before each or setup functions in tests. Is that deliberate, or do you just not have the deed for them right now? No, that's actually deliberate. What I find is that before each tends to make your code a little bit harder to read, and it tends to get, if you're not careful, it tends to get really complicated because different tests need different setup. So what I do instead is I just do all my setup in a function. For example, here we've got get async or start and stop async. In our route 13 server tests, we have start server async. These are effectively our setup functions, but now they can be configured, and they can be configured differently depending on what the tests need. So it's just normal function abstraction, calling a regular function. It makes your test easier to read because now you can see every single thing that's needed to set it up, and it makes your tests and all the complexity of the different cases, rather than setting up 5 different things for 5 different types of tests, we can parameterize it so the test sets up exactly what we need. So I just find that it makes the code clearer. Okay, so we're going to respond to our requests with a placeholder. So I'll go ahead and start our server async, and again, this is the equivalent of our before each. But I don't need any special arguments. I don't care what the arguments are, so I won't pass those in. It's programmed to have a default that works. Then we're going to want to simulate request async. So we'll await that. And then at this point, we should expect that the last thing written to standard out was request or received request. And I expect that that won't happen because we haven't coded that yet. And in fact, that's true. The last thing that was written to standard out was server started. So let's come over here and let's modify our onRequest async to say command line dot write standard out received request. There we go. And now we need to make sure that we are getting the correct response. Nicholas Luxmith says, maybe you already answered in a previous episode, but would you also put the nullable infrastructure code into the production code in a language that supports interfaces and subclasses? Or would you add the code into a specific subclass that's only used for the tests? That's a great question, Nicholas. Let me answer that after we finish this because we're almost to the end. And we do talk about that a bit more in the Testing Without Mocks episode, but I'm happy to answer that for you today. So we're almost done here. We just need to declare that the request, when we respond to a request, that we get the right request back. So let's assert that or right response back. So let's assert that our response is equal to a status of 501 with a header of content type text plain and charset UTF-8 and a body of not yet implemented. That's going to fail because we're not getting that. Instead, we're getting request handler returned invalid response. So nice to see that working. But now we should be able to return what the correct thing is, and hopefully that will work. And because we're using sociable tests, since this code worked, it's actually calling through to the real server code. It's not running a real server, it's running a null server, but it's calling to the real server code, which means that this should also work when I test it for real. When you use sociable tests, generally speaking, works the first time. So let's go ahead and try it out. We're going to hit localhost 5000. We should see request received on the command line and not yet implemented on the browser. And that's exactly what we got. Works the first time, every time. Well, almost. So let's, and there we go. That is our code. I'm going to go ahead and check that in. Uncle Scientist asked, why did we get 2 requests received? And that's probably because the browser asked for the fave icon. Let's go ahead and check this in. Route 13 server responds to requests with placeholder. There we go. Okay, so that is microservices without mocks responding to requests in a way that's reliable and robust. It's been gone a little bit long. It's 1 o'clock, and normally I would stop here, but I'm going to stay around to answer a few more questions if you have them. So if you have any more questions, go ahead and put them in the chat. I'll get to Nicholas's in just a moment. Before that, a couple of quick announcements. Our next live stream is going to be next Tuesday. That's June 16th. And we're going to continue this microservices without mocks exercise. Next time, what we're going to do is deal with requests. Obviously, we're seeing that we're making a response, but we're not actually doing the route 13 transformation. So next time we'll get a request with something to transform on it, and we'll actually do the real transformation. I also want to remind you that if you liked what you saw today and you'd like this sort of agile engineering training for your own teams, I can do that for you. And what I do when I work with private training is it's always going to be usually in your code base if that's what you want, and it's always in your language, your library, your frameworks. So it's something that sometimes these ideas are hard to apply. It's easy to see in the classroom setting, but it's hard to apply for real. I can actually help you apply it for real. If that's something you're interested in, go ahead and send me an email, jshore@jamesshore.com. Visit my website, jamesshore.com. Send me a tweet at jamesshore. Whatever you do, I'd be happy to talk to you about what's going on at your company and how I could help. Okay, let's take some questions here. First off, Nicholas Lockschmidt was asking about the nullable infrastructure code. So if I wasn't using JavaScript, which of course is a dynamic language, how would I actually code that nullable infrastructure? I still would code it effectively the same way, but I would have to use interfaces. And if the code that in some languages, in C#, they're usually pretty good about having interfaces for everything. So I would just make my embedded stub, which you see here, I would make that extend the same interface the real thing does. If I wasn't provided with an interface, now things are a little bit trickier. And what I would probably have to do is make a tiny, tiny little wrapper just for my stub that provided an interface, called the real thing in one implementation of the interface, and ran the stub code in another implementation. It's a little bit uglier. It's not quite as nice as this is, but it does work. So hopefully that answered your question, Nicholas, and thanks for asking. And then next I'm seeing Uncle Scientist asks, why does the ... have a new line in the middle? It's only because I pressed enter while the tests were running. It's nothing more complicated than that. All right. Thank you all for your questions. Thank you for joining me today. That is it for this time. Again, our next live stream is in a week, Tuesday at noon Pacific. That is June 16th, and we're going to be continuing this exercise of microservices without mocks and looking at handling requests. That is it for this time. Thanks so much. I am going to upload the finished code in just a minute with the tag 2020-06-09-end. Thanks again, and I will see you all next time.